So the next characteristic of SMAC is overhearing. So using this SMAC, this overhearing is avoided, and let's see how exactly it's avoided. So once a schedule is established, the data packet transmission are performed during the data period of the listen interval. So we have this listen interval. So over this entire listen interval, so during the data, after preparing the schedule, so during this time interval, that is that which belongs to data, actual data communication happens. So once the schedule is established, data packet transmission are performed during data period of the listen interval. Nodes that have a packet to send content for wireless medium during the data interval. So basically during this interval, starting from here, right after sync message, we have this entire field. So during this time interval, they'll content for the wireless medium. When a node transmits its RTS packet, so over here let's assume that A is having some data and it has to pass its data to node D, and in order to communicate to node D, it has to go through node B and C. So right now our node A is having data, so thereby right after sync field we have this data interval. During this data interval, so it sends ready to transmit, so that will be conveyed on to node B, and the node B will in turn answer that RTS through CTS, that is clear to send. So when this clear to send reaches node A, it will only then it will send its data, and when this data reaches node B, it is confirmed that transmission was successful through an acknowledgement from B to A. So this is how the process happens from A to B. So when node A transmit its RTS packet, the intended receiver sends back a CTS packet during the for CTS interval. After this RTS and CTS exchange, the transmitter node starts to transmit its data packet. Other nodes in the virtual cluster switch to sleep state until the end of the frame, and this avoids wasting energy during idle listening and is referred to as overhearing avoidance. So basically when this message is being communication is happening between A and B, on the other hand node C, that which is in the same vicinity of node A, so it will turn off its radio and will automatically enter into sleep mode, and during this interval it also gets to know about the data communication duration also. So because when by the time node A sends its RTS to node B, it also adds the entire time duration of data communication. So thereby this node C enters into sleep state. So thereby from here to here you can see that this overhearing is being avoided by node C. Now over here the drawback with SMAC is that, so here you can see that the data is already with node B, so and it is confirming that data has successfully reached it through acknowledgement packet to node A, and right after that, after getting the entire data, it could start communication with node C, but here this node B has to wait over this entire sleep interval because of synchronization. It has to wait, even though it has data, but it has to wait. So B has to wait even after having data from A, since C is sleeping. So this node C sleeps over entire time duration, and only during the sync packet interval, so it will wake up. So this is the disadvantage of SMAC. And the other disadvantage of this SMAC is that local interaction but WSN is of multi-hop in nature. So here you can see that during one interval, only from one node to the other node we can communicate, not over an multiple nodes. So thereby we can think of it as local interaction. But WSN's wireless sensor network basic nature is multi-hop. So here you can see that one frame and only one hop is possible. So here you can see that over an entire one frame only one hop is happening, that is from A to B. So if it were over an single frame, multiple hops were, if at all, if were possible, then it would have been much more efficient. And thereby, because only one hop during an one frame is happening, so here we can easily calculate the average delay, that which is directly proportional to length of the path. And here WSN basic nature is multi-hop, but this multi-hop is actually taken care at network layer, because right now we are at MAC layer, medium control access control. So that's the second layer after the physical layer, and above this MAC layer we have this network layer, and basically in network layer this multi-hopping task will be taken care of. Then we have this next characteristic as multi-hop awareness. Multi-hop communication is mainly handled at the network layer in the conventional layered structure. Considering this fact of MAC design brings various advantages. So this is commonly referred to as multi-hop awareness. Disadvantage of SMAC protocol is that it can only do this local interaction and only a single hop operation. Then we have this next characteristic as adaptive listening. So whenever this A transmits RTS packet to node B, C overhears this and it switches to sleep state, and it gets information about the transmission duration in RTS and CTS packet. So adaptive listening mechanism reduces the latency of the basic SMAC protocol by half, and it's a best effort solution, because so for adaptive listening, as I said, it's the best effort solution. Here you can see that by this adaptive listening, here if I compare it with that of this graph, here node B has to wait over an entire period because this node C is sleeping, but whereas here, because of adaptive listening, here node B is, after node B getting the data from node A, it is not at all waiting, so it can directly send its data to node C by RTS and CTS handshakes, four-way handshaking. So BTS is not waiting over here, so thereby it's called as best effort, because the same thing is happening over here. As you can see, after B getting the data, after C getting the data, it is still waiting for node D to wake up, and here is it could have started its four-way handshake signal right after getting the data, but it is not happening here, so thereby we call it as best effort. So this concept we call as adaptive listening mechanism of SMAC. So this is adaptive listening. Then we have this multi-hop awareness, and before that we had this overhearing and periodic listen and sleep. So SMAC has lot of features in it. The very first one is periodic listen and sleep. Next we have using this SMAC, this overhearing can be reduced, and then we have this multi-hop awareness, where SMAC can be thought of as local interaction, but WSN nature itself is multi-hop, but this multi-hop thing is taken care at network layer. But this MAC layer should have an awareness about this multi-hop. Adaptive listening. So basically in adaptive listening we have this best effort kind of case where B, after getting the data, starts to do this four-way handshake signals directly with node C, but whereas C to D it's not happening. C node is still waiting for node D to wake up. So this is adaptive listening mechanism of SMAC. Then we have this concept of message passing, and in the concept of message passing can be applied onto sensor nodes, a lot of sensor nodes where it is associated with large burst of data. So default SMAC operation results in large overhead because of this RTS and CTS handshaking signals. So here you can see that before the transmission of data, RTS and CTS handshaking signals are must here in SMAC, but this, by using the concept of message passing, SMAC can reduce all those overheads, and let's see how exactly it happens in message passing. So only for the first packet exchange this RTS and CTS handshaking signals will be done. Each packet is followed by an acknowledgement. So here you can see that only for the at first only one time this handshaking signal is happening. Right after that you can see data is getting propagated from node A to node B, and on the other hand acknowledgement is being sent from B to A. This is for the other data, third data, fourth data packet. So this we call as message passing. So each packet is followed by an acknowledgement. Remaining duration of the burst transfer is included in each packet by the sender, so that this node C can extend its sleep duration. Acknowledgement message from the receiver is to prevent hidden terminal problem. So here it could have directly transmitted this data from data 1 to data 4, but it is also associated with these acknowledgement packets just to avoid hidden terminal problem. So this is about message passing associated with SMAC. And if I were to qualitatively evaluate this, there are some advantages associated with SMAC. That is, it consumes less energy compared to that of CSMA, collision avoidance protocol, and it mainly suits to lightly loaded networks where there are less number of nodes as well as less number of data. And the third one is energy savings, and in order to do this energy saving we make use of all these concepts of in SMAC. That is, the very first one is avoid overhearing. That is, a node will turn its radio off when two nodes are communicating with each other, and if that node falls in their vicinity, then is message passing. Large burst of data can be passed through this message passing. Then we have this sync message, and because of the sync message virtual clusters can be formed. And there are some disadvantages of this SMAC. That is, it assumes that the traffic is constant, but in wireless sensor network the traffic may vary depending upon the timing condition as well as the environment, and here the duty cycle is fixed and it's not flexible. All nodes should wake up for synchronization. So here you can see that this node C, after entering to the sleep mode, it could have been in the sleep mode all the way long, but it is waking up in order to just to check the carrier. So thereby all nodes would wake up for sync packet, and that which is a constant energy sucker due to duty cycle scheme. And basically this SMAC is not applicable for high density traffic and delay sensitive data, and all those drawbacks can be overcome by making use of Berkeley MAC. And in our next video tutorial we'll see how this BMAC actually works and how better is this.